All right, guys, so today we're actually going to be talking about rational functions. Today we're actually going to be working with rational functions. The rational function is a fraction whose numerator and denominator, the top and bottom, are non-zero polynomial functions. So we're going to have variables in the top of the fraction and the bottom, in the numerator and denominator. The domain of a rational expression excludes values that make the denominator 0. We cannot have 0 on the bottom of a fraction. So we have to exclude any values. So if we had 6x over x, anything that's going to make the denominator 0, any values of x that's going to make the denominator 0 must be excluded because we cannot have them as a value for the function. And a rational expression is in simplest form or in simplified form when its numerator and denominator have no common factors. That's why we went over factoring last week, this first few weeks, because we have to get it in simplified form. Now, no common factors other than, well, plus or minus 1. You can have a common factor of 1. Everything has a common factor of 1, but factoring it out does not change anything. So as long as it has a common factor other than 1, then it is in simplified form. Now, simplifying, kind of they gave this here, and I included this here. Simplifying rational expressions is really simplifying anything that's in common on top and bottom. Now, it doesn't just have to be a number. We can also have expressions, x plus 3 and x plus 3. If it's in common on top and bottom, we will simplify it out completely. Sure. All right, so anything that's in common on top and bottom, we're going to simplify it out. It simplifies completely. Or really, this is just going over the fact that anything divided by itself is 1. So we want to make sure when we're simplifying radical expression, there's nothing in common on top and bottom. So what can we simplify in this expression, this first problem here? So what's in common on top and bottom? Because we do have the 4 and 2, right? But what is the 2 with? X. So this here, let's get a highlighter. X plus 2 is one whole term. Because the plus and minus, anything we add or subtract is connected as a whole. So if I was going to simplify the x plus 2, I would need x plus 2 on top, yes? Do we have x plus 2 on top? No, okay. Well, if I want to simplify the x, let's get a highlighter again. If I want to simplify this x, I need an x on top, yes? Do we have an x on top and bottom? Is there anything we can simplify? No. So this here is as simplified as it gets. Now, if we had a number 2 on bottom, if it was 2x instead of just x, then we could have simplified the 4 and 2. But here, the x plus 2, anything in parentheses is locked together. Anything without addition or subtraction is locked together. We can't just cancel things out. Okay, let's look at this one here. Now, is there anything we can simplify in this one? Yes. This x plus 1 and this x plus 1 are in common. They share a similarity, yes? So we can simplify those out. So what's left on top? And what's left on bottom? And that's simplified. Because really what we're doing is it's almost like we say this is being multiplied by x plus 1 over x plus 1. And anything divided by itself is 1. It simplifies out. And that's really what we're doing. Okay. Is this as simplified as it gets? Did I do anything if these were in common? Could I simplify? It's that 3 was a 4. Could I simplify it? Why not? Yes. Move that over there. Even though I didn't write these in, they're still there. Because when we have things added or subtracted in the denominator, they are stuck together. They are locked together. So if it's helpful to remember to just include those, that's fine. But even if we just have two terms left over, like the x plus 3, they're still locked together in the denominator. All right. Looking at this here, what can we simplify? So the x squared and x squared, we see that on top and bottom, yes? Wait a minute, what did we just say about addition and subtraction signs? The x squared minus 4, those two are locked together. The x squared minus 4x minus 12 on top, those are locked together, yes? It is not. Well, what did we spend most of this first semester so far going over? Factoring. Will the denominator factor? It can. Because x squared minus 4 is x squared a perfect square. Is 4 a perfect square?
Yes.
So is that a difference of perfect squares?
Yes.
So we would have plus and x and x. And the factors of 4 are and 2. This is where I would start. On these here, when we're simplifying, figure out which one. So here we only have 2, because we'll eventually get more sets of polynomials that we'll have to factor. Find the one that you can factor the easiest. Find the one that you find easiest to factor, x squared minus 4. Difference of perfect squares, x minus 2, x plus 2. Yes? Now, on top, 2 sets of parentheses. We're going to have our 3 spots and 3 spots. Now, what we want to have happen is what? We want one of the sets of parentheses on bottom to match one of the sets of parentheses on top, yes? Because that's the only way we can simplify anything, is if something matches, yes? So what do I know one of those parentheses has to be? X plus 2 or x minus 2, right? Because if it's one of those, then they would simplify, yes? Okay, well, let's look at this here. So the numerator, well, the 12 is negative, so our signs are what? Positive, negative. Factors of x squared are x. Okay, let's look at factors of 12. 1 and 12, 2 and 6. Okay, is there one of those sets of factors that you hope would work? 2 and 6, yes? And now we can still check it, because x times negative 6 would be negative 6x. 2 times x would be plus 2x, and that would give us negative 4x. So that's what we wanted, yes? Okay. We have a set that matches, yes? So those would cancel out. These would cancel out. Leaving us with any questions on this here so far? Okay. We're almost done with this here. Now, again, we said the denominator for these cannot be what? 0, right? Because that's been drilled into y'all's head and been means after means of dividing by 0, yes? When we look at this here, because this here, x minus 6 over x minus 2, this is the simplified form. This is as simplified as it gets. Now, x cannot be, see the highlighter, see light blue. Any value that's going to make the denominator 0. Now, we don't look at what we finished with, what's simplified. We look at what we start with. So we're looking at this here. X minus 2 and x plus 2. I need to see what values of x is going to make these 0. These are our restrictions. Now, there's two ways we can go about finding this. Okay, good. I'm going to move him over here. There's two ways we could find this, because we said x plus 2 and x minus 2. Neither one of these can be 0, correct? Well, I need to find what value would make it 0, yes? So what's an easy way to see what would make x plus 2 0? X plus 2 and... So what do we want? We want to see where it is equal to what? 0. I can set it equal to 0, yes? Because it can't be 0, and I want to know what value is going to make it 0. So why not just set them equal to 0? Because if I set them equal to 0 and solve, will it tell me what values of x would make those spots be 0? Yeah. Well, yeah. Now, for some of them here, I mean these, here I would subtract 2. And it'd tell me x is equal to negative 2. And here I would add 2. So really x cannot be negative 2 or positive 2. I mean, if we wanted to simplify it, we could say plus or minus 2. Because if x is either one of these values, it doesn't work for this function. Even though the x minus 2 is not in our final simplified form, we still include it because it is a restriction on the beginning function, on the one we started with. Questions on this here? Questions on this here? Normally, we should do this before we end up simplifying, but you can do it on the back end too. All right, let's look at another one. So we're going to factor, and then we can see what x should not be. X squared minus 9 is a difference of perfect squares. Yes? So how would it factor? X plus 3 and x minus 3. So what do we think? 3 and 4, which one positive, which one negative? And just to make sure we can check, x times negative 3 would be negative 3x. Positive 4 times x would be plus 4x, which would give us positive x. I mean, we can keep those the same. We just need to flip the signs, and that will work. So it should be negative 4 and positive 3. Now, we could simplify at this point here, but let's go on and see what x cannot be. Well, x, the denominator cannot be 0. So to find this, well, we can set x plus 3 equal to 0 and x minus 3 equals 0. So we can set everything on the bottom of the fraction as part of this rational function, the denominator, equal to 0 and solve. Well, for the first one here, we would subtract 3 from both sides because those will cancel. telling me x is equal to -3. The other one we would add 3. That'll tell me x is equal to 3. So x cannot be either plus or minus 3. Now, it's not always going to work out that we have plus or minus the same number. They can have different restrictions. It just worked out on these first two that our restrictions are the same. Okay. Any questions on any of this so far? Okay. Let's simplify this fraction. What will simplify on top and bottom?
3.
Right, the x plus 3 and the x plus 3. Which would leave us with what? And that's it. That's all we have to do with this here. Any other questions on this here so far? Okay. Can we factor anything with the numerator? Can we do anything to the numerator? No. It's x plus 4. One of the other signs, again, what is the biggest exponent on top? 1, because we don't have anything to a power, written power, so it has to be 1. X is always to the first power if it's not written. So that tells us that this is as simplified as it gets. Because we can only really factor if the biggest exponent on top or bottom is greater than 2 or greater, so quadratics or higher. So we can't do anything to the numerator. How about the denominator? Okay. So what would we have? Well, plus and minus. Because hopefully you're starting to like the difference of perfect squares a little bit, because it works out kind of nicely. Probably one of the easier ones to factor. Yes, especially if you can see the perfect squares. Okay, so we have this here. Now we could simplify, but again, we need our restrictions. We need to see what value of x, what values of x we cannot have. What we need to set it up is x plus 4 is equal to 0 and x minus 4 is equal to 0. So for our first one here, we would minus 4 from both sides because those will cancel, leaving me with x is equal to. And over here, we're going to so x is equal to okay. So our restrictions, x cannot equal plus or minus 4. I'm just rewriting it down here. So we'll have it just in case this goes away when we scroll down. Now what simplifies? Let's x plus 4 and x plus 4. Okay. Now on the bottom of the fraction, the denominator, what's left? Okay. What is left in the numerator? 1. It will be 1. Because again, anytime we simplify or factor or divide, because anything divided by itself is what? 1. Anytime we simplify down, we will always simplify to 1. We will never simplify down to 0. Yeah, it works out with multiplication and division. No matter how we multiply two things or divide two things together, we will, unless one of them is 0, we can't get to 0 with multiplication and division. One of them has to be 0 for us to get there. Right, for these problems here, when we do these, so it's going to ask you, one, to simplify it, and what are their restrictions. So it's going to ask for both. It's going to ask for the restrictions and what it is when we simplify it. So questions on this here? Okay, looking at this here, which one do we think is going to be easier to factor? The numerator or the denominator? Okay. So we have two sets of parentheses with 3 spots and 3 spots. Since the 6 is negative, the signs are going to be what? Opposite, positive and negative. Factors of the first term would be? Bless you. X and X. So those are not too bad so far, right? Because we have opposite signs because it's 6 is negative, factors of x squared are x and x. Factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try? 2 and 3. Again, we can check it, so we do multiply through, so x times negative 3 would be negative 3x. 2 times x would be plus 2x, which gives us a negative x. Is that what we wanted? Well, yes. Okay. So x plus 2 and x minus 3 are the factors of the denominator. Okay, let's find the factors of the numerator. So since the 3 is negative, the signs are factors of x and x. What are the factors of 3? 1 and 3, yes? Should the 1 be positive or negative? Why is that? What do we have on bottom? We have an x minus 3 on bottom. So what do I want on top? An x minus 3, because if this is going to simplify, I need something that's going to be the same on top and bottom. Why did I ignore the x plus 2? Well, what are our factors of 3? 1 and... Is there any chance that I could have a 2 in either one of these places? Well, no, it's either going to be a 1 or 3. There's no chance of having an x plus 2, correct? So why would I pay attention to that one? Well, I wouldn't, because if I'm wanting these to be the same, well, hey, it does have a 3. If this is going to work, I need the x minus 3 to match up, yes? So I would set it up this way. And if, again, if we checked it, it does work out, because x times negative 3 would be negative 3x. 1 times x would be plus x, which will give us negative 2x that we wanted. So this is how it factors. So even though we are factoring multiple things, if we can find one that's a little bit easier to factor, it kind of gives us a roadmap or a hint at what the other factors might be. Okay. Well, now we need to find the restrictions. We need to find the restrictions. We don't need that symbol yet. Because if I want to find out what's going to make the denominator 0, well, I can set the terms in the denominator equal to 0. So the first one here, if I want to see what makes it 0, I would subtract 2 from both sides. And these would cancel and tell me that x cannot equal. And the other one we would add 3 to both sides, and it'll tell me x cannot equal 3. So x cannot be negative 2 or 3. Yes. Last thing we need to do is simplify. So what would we simplify? The x minus 3 on top and bottom. And that leaves us with what? X plus 1 over x plus 2. And that's all we have left. And that's as simplified as it gets. Questions on this here? Okay. Multiplying rational expressions. So if I multiply two fractions, a over b times c over d, well, we multiply the numerators together and the denominators together. We multiply straight across. That's what we did with fractions, yes? Because if we did 1/2 times 1/4, we did 1/2 times 2/3. Well, what would we do? We would do 1 times 2 and 2 times 3, yes? Well, 1 times 2 is 2. 2 times 3 is, does that reduce? What it would reduce to? So even with these variables, we're going to do the exact same thing. We're going to do the exact same thing. We're going to multiply everything on top with everything on bottom. And then simplify down. Anything that's in common on top and bottom will reduce. Find the product of these two here. Well, if I'm multiplying two fractions, the numerators multiply together and the denominators multiply together, yes? So for multiplying the numerators, well, I'm going to have what? 8 times 7. Then we're going to have x to the third times x to the fourth. And then we're going to have y times y cubed, yes? We will. I'm just rewriting it out so we can see it. Okay. So if you are able to kind of go straight to actually combining them together, that's fine.
Okay, that's thank you.
No, you're good. I'm just writing this out so we can kind of see it as we go through this. Now in the denominator, we'll have 2 times 4. X is by itself, so we just have x. And then we'll have our y squared times y. And we have this here. Now the textbook goes in two different directions with this here. They say there's two different ways we can do it. One of them is that, well, I can rewrite these as prime factorizations. So that would be kind of looking at 8. It would be 2 times 2 times 2. 4 would be 2 times 2. Writing them as their products, multiplication. Which is like, for us, okay, with 8 and 4, that's fine. But that means here, I'm going to have x times x 3 times. Here, it's going to be 4. Here, I'm going to have, we start bringing these and expanding these out a little bit farther than we need to. The other method, and I think this is what most, and this is what we'll probably be doing more often, is looking at these here. 8 times 7 is what? 56, yes? X to the third times x to the fourth. When the bases are the same, we add the exponents. When the bases are the same, we add the exponents. So 3 plus 4 is 7. Y times y to the third. Any questions on in the numerator, the top of this? Well, 2 times 4 gives us what? Well, we only have one x, yes? Y squared times y would be y to the third. Questions on this here? Any questions on any of this here so far? Do we have anything in common on top and bottom? Because there is a common factor here, yes? There are common factors between these two here. So we can simplify that. Now, if you do have some trouble seeing it, the yellow calculator is the TI-30XS. You can type those numbers in. You can't type the variables in. Don't type the variables in because it'll most likely give you 0 as the overall answer. But we can do 56 over 8. Type it in as a fraction, hit enter, and it will reduce it for us. Now, it'll tell us that it is 7. And I'm going to do this here just in case, because if we have anything left on top and bottom, something on both, we'll still need the fraction. But it might turn out we don't. We'll see. Okay, because 56 over 8 will reduce to 7. I have 7 x's on top, I have 1 on bottom, yes? So we can take away 1. Now our property with division, if two things are being divided, if like bases are divided, what do we do with the exponents? We subtract. So how many do I have on bottom? 1. 7 minus 1 is 6. Would it go on top or bottom? Top, because they are bigger on top. Questions on this here? Why to the fourth and why to the third? So we can do 4 minus 3, which leaves us with what? 1y, and would it be on top or bottom? Do I have anything left to simplify? So, so we look at the restrictions. So we can look at this here, or this here, because both of these, we have not simplified anything out. We haven't removed anything for the bottom of the denominator yet, correct? Now we look at this here. We'll look at this one, because this is a little bit nicer looking. X and y, there are two variables in the denominator, yes? Is there anything being added or subtracted to this here? No. Is everything being multiplied together? Yes? What did we say? If there's more than one thing multiplied together and they equal 0, one of them has to be 0, yes? So if there's nothing really added or subtracted, it works out that these cannot be 0. Because here what we're really looking at is 8xy cubed equals 0. Well, really we can divide both sides by 8, telling us xy cubed is equal to 0. Our 0 product property says any two or more things multiplied together equals 0. One of them has to be. So we're saying x is equal to 0 or y to the third is equal to, well, that's already done. X cannot be 0. And if we cubed root both sides, well, it's just saying that y cannot be 0. So it works out either one of these cannot be 0. Questions on this here? Are we good with this here? Yes? Okay. There it is. Now, we're going to look back at this here. We're not going to quite move on to the next one. And this here, again, you don't have to write this down. We can look at this. Because again, we said 56 divided by 8 is 7. We can do that in a calculator. That's not too bad. Now, we also said when bases are the same, we subtract the exponents, yes? So x to the 7 over x to the first is really x to the 7 minus 1. Because that's what we're doing. We're subtracting the exponents. In this exponent rule, we really write it out like this here. So we can actually write this step out. The fact that we're subtracting those exponents, yes? Now, at this point here, well, we can say, well, 7x, yes, 7 minus 1 would give us 6. 4 minus 3 would give us 1. But we got to the same answer, didn't we? So this is a way that you can write it out so you're not trying to keep track of everything in your head. You don't have to do it in your head. We can actually write this step out, this step here, so that we can see how it works. Questions on this here? So this is where we're stopping here for today. Okay.